Friend came up to me and said, hey, I want to start a coffee business, but I don't know what to price my coffee beans at. Can you help me? And I was like, of course I can. We can do some market research, scrape a few sites. It's dead easy. And in this video, I'm going to show you how easy it is to scrape generic e-commerce sites to pull price information you can do for your own analysis. So all I did here was Google coffee beans and picked a few shops. We have 1, 2, 3, 4, 5, 6. The first one here, what we're going to do is we're going to straight away, we're going to look at the URL. What we're looking for is two different things. We're looking for to see if this is a Shopify store. If it is, you're likely going to see something like collections and products like so. If it is, just type .json at the end of the product. Now you see it's kind of loaded, but it went back on itself there. That's interesting. So we've got two choices. You can try and go a bit further back and find the JSON, or you can do view page source. I'm going to do line wrap here and make this a bit bigger so we can all see. And then you want to search in here for one keyword called offers. And what we're looking for here is within our schema, which is this. I'm going to zoom straight back out a little bit. Go back up to this one. And look right here, we have inside this script tag, application LD plus JSON, we have this context, schema, product, offers. Here we go. So it tells you all the prices for the SKUs, etc., etc. So we can log this and we can visit this page as many times as we want to. We can come back to it, check the SKU, check the current price, log it, make note. Again, let's go to the next site here. So this isn't a Shopify store. There's no collections or products like that. But let's go back, view page source, line wrap, and what's our keyword? Offers. So I missed it. It was the very, very first one here. Here we go. Now this is exactly the same JSON. It's just formatted, it's just all in one line as opposed to be neatly split out. But this right here is going to have the offers, the type, and the price, and the currency, and the SKU. So again, we can come back to this page as many times as we need to every day, check the price of this product. Scaling up your code is one of the biggest problems we face when scraping data, and I always recommend the first step is to use a high quality residential proxy. With Proxy Scrape, the sponsor of today's video, we have access to high quality, secure, fast, and ethically sourced proxies that are perfect for our use case. There's 10 million plus proxies in the pool to use, all with unlimited concurrent sessions from countries all over the globe, enabling us to scrape quickly and efficiently. I exclusively use residential proxies as these are the best option for beating any anti-bot protection on the sites we're scraping, and with the auto rotation, this is the simplest but most effective way to avoid our projects being blocked and allow us access to the data that we need. It's only one line of code to add to your project, and then we let Proxy Scrape handle the rest from there. And any traffic you purchase is yours to use whenever you need, as it doesn't ever expire. Other options though is if you just want throughput, then data center proxies with unlimited bandwidth, 99% uptime and no rate limit from reputable countries, and IP authentication make them a very easy to use and attractive option within the right use case. So if this all sounds good to you, go ahead and check out Proxy Scrape at the link in the description below. Now let's on with our project. Let's go to another one. Let's try the .json on this one. Okay, that worked. Even better, we can just go to the product, put .json afterwards, and here's all the product information, literally everything. This is just the whole Shopify thing here. It'll give you everything, the SKU, the price, everything that the customer, everything that the retailer has put in, including all of the variations. So again, these should have a SKU. Yep, there we go. So you can come back to this product as many times as you need to with that unique identifier. Here's another one. This one looks like a Shopify store as well, but again, if we do .json, it's going to redirect us back. So we have a choice. We can do, let's try products.json. Okay, the main one worked. So this gives us every product on this website now, instead of just the one that we were looking at, so we can loop through this. And what you can do as well with this one is you can put query parameters after it. I think it's limit, and I think 250 is the most. That needs to be an equal sign. I think 250 is the highest. So you see it's taking even longer. So if I shrink this down, 148. So I've got every product on this website now with all the product information that we could ever want. So there's another one. Here we go again. Here's another products one. Again, this would be a Shopify store. We could do the .json. I'm going to show you as well here that if we go to offers again, here we go. Here's the data that we wanted. And this is in exactly the same format for every site. This is a schema. This is a generic way of sending this information to the front end from their back end data. This is really important because what this means is we can create one single model and we can pull this schema out from any of these sites, stick it straight into that, and it's going to work just fine. I've got one more to show you. Again, here there's products, so this is probably a Shopify store. It is, there we go. Again, you can do that way, or if I go to view page source, come here, offers. No, it doesn't have it in this one. Let's try schema. Okay, so this one isn't going to have this piece of information in. Oh, there it is. Oh, this one has this is different. This has the question schema. You can see it right here, FAQ page. That's interesting. Again, we don't need that though, because this was a Shopify store, so we can do .json at the end and it will work. So what I'm going to do now that you know how to do this, is I'm going to go through and I'm going to code out an example to pull each of the product information from all of these stores. We'll do it one by one. We'll get all that information. Then I'll show you how to create a model to save it all, and we'll save it all to a neat CSV file or something similar, maybe a database, so you get the idea of what we're trying to achieve. Now, there's one thing that's really important. Quite a lot of the really big e-com stores do use this method with the schema, but it's going to be slightly different, and it's probably going to be a little bit more difficult to scrape because, you know, these massive stores, these massive companies have a lot more bot protection. Again, we need to use those proxies that we talked about earlier. But what we're trying to do here is have a look and pull from lots of different stores for that kind of like, you know, authentic type thing. And not your Amazon, but, you know, you kind of like, yeah, whatever this is, the rave coffee. That I mean, I don't want to drink this, but maybe you want to try it. This sort of thing. So you got to keep in mind what you're trying to do and what you're trying to achieve. So let's go ahead and write some code, scrape all this data, save it all out, so we have a nice neat piece of code that we can run every day, get these prices. Let's start off with the simplest version that we can. So I have created a project folder and started my virtual environment, and I've installed a few things. So you're going to need to do curl-cffi. This is a really good wrapper around requests that makes our requesting to the server a bit easier, because we can impersonate a browser. I'm going to use selectolax to pass some things, rich to help me with printing, and I chose to use or.json to pass the JSON in this particular project. You could of course use the standard JSON library if you wanted to. So inside my main.py file, we're going to import what we need to start with. Let's make this a little bit bigger. Just these things that for the moment, and as I said, curl-cffi is an import as a wrapper around request, so it imports as requests and use it as standard. Oh, you need rich as well. I've set the URL as one of the products that we just looked at. This is a Shopify one, but we're not actually going to go to the Shopify products.json. We're going to use the schema because that's the consistent thing that I'm going to use for this project. I'm going to create my request with responses equal to request.get. And you'll notice with curl-cffi, we have this impersonate thing here. That just sets some of our extra parameters and everything to sort of make us look a little bit more like a Chrome browser. Not necessary possibly for this, but good practice to use. Then we take the HTML parser and give it the response.text and create our HTML variable. From here, we just need to find all of those script tags that we just looked at that had the JSON data in. They are usually application/ld plus JSON, and this is the CSS selector to get all of them. With selectolax.css gets everything that matches, so this is going to return a list. From here, we want to loop through that list because this tag can hold all sorts of different bits of information. We only want to find the one that has the word offers in the script.text. This matches the schema for the product and is a good key to use. From here, we're going to take that data and we're going to load it into a data variable here. Again, this is where I decided I wanted to try or.json. You can of course absolutely use the standard JSON package in Python to do this. There's no benefit to or.json here. I just wanted to try it out. Then I'm going to do is just print data.get the offers part, just so I can see the offers section here. So I'm going to save this. I'm going to come over to our run code and we're going to do python 3py main.py. And this is going to return us that small section of data that holds the offer in. So if I was to come back here and just print the whole thing and run it, we're going to get all of that schema back here. So if I go to scroll mode, you can see here was the offers section that I printed out earlier, and here's the rest of the information that matches it all here. So this is the easiest way to do it. It's 14, 13 lines of code, depending on what you're trying to do. But we want to expand on this. We want to make this much better, much more robust. We want to take the data from multiple URLs and we want to store it into a database with timestamps against the imports, against the scraped parts of the offer data, so we can start to collate those prices. And that's what we're going to do next. So now we've seen a basic example. Let's expand on it and make it something that we can actually use by adding in a database and getting it to a point where we could run it every day or whatever and add the prices in. So we're going to create a new project here in this folder. I'm using UV for my project management at the moment. It's a pretty cool tool by the same people that make Rough. So I'm going to do UV VMV, and then I have a ACT UV, no UV ACT, which actually is a shortcut to create the virtual environment for me and activate it. Now I'm going to do UV pip install. We're going to need quite a few things here. I'm going to use HTTPX this time. I prefer that. I'm going to use SQL Alchemy for the database. And we're also going to need rich. And we're going to use a thing called extract, which I will show you when we get there. It's just a nice, neat way of doing those things. And if you spell SQL Alchemy correctly, we get it going. Okay, cool. So let's think about the structure of our project. We're going to have a few different files. I'm going to create them now. We'll have our main.py file to run everything, and have a database.py file, which is going to hold the main database connection that we can use, models.py, and we'll also have, I think that's probably it for now. We're also going to have our urls.csv. Let's put that in as well here. So I'm going to open this in my code editor, and I'm going to go straight. Actually, what I'm going to do first is I'm going to do git init. We're going to use this. We're going to use git, and I'm going to do a git ignore. And we're going to say, well, let's ignore any venv and any pycache folders. Cool. And now when I open up Helix, we get just our working files here. So let's start with the database one. The idea of this is we sort of create something where we can initialize our database and hold all that good stuff. So we'll do from SQL Alchemy, we're going to import in create engine, and from SQL alchemy.orm, we're going to import in session maker. The session is what we're going to use to actually act on the database. And we're going to import the models. I'm going to do from models. We're going to import in, I haven't yet to create these, but there's going to be base model, there'll be a product model, and an offer model. We will create these in a minute. And I'm going to say that our database URL, I suppose, it's going to be SQLite. We're going to use an SQLite 3 database. And we want to do 1, 2, 3, and then put it in this folder called products.db. Does that look right? I think so. Now we can say that our engine is going to be equal to the create engine, and this is using our database URL. I'm going to put echo is equal to true on for the moment so we can see everything happening. And I'll say that our session local is going to be equal to the session maker. And this is going to do, I don't know, what do we need? Let's do auto commit, I think. False, auto flush. I'm not sure if these are necessary. I kind of just got in the habit of doing them. False. This one is though, bind equals to engine. So we can now have our session, which we can act on. Do things on our database. Let's create a new function. We'll call this one our initDB function. And when we call this function, when we run it, we'll have our base model, and this will be metadata.create all, and the bind is going to be the engine. So we're basically just setting it up. So once we create our models, we call this function from our main.py file, and it will create the models, create the tables and everything for us when we need them, and it will create a database or connect if it doesn't exist, and give us a session that we can actually work with to query it. Cool. So let's save this and go to our models. In our models.py file, let's start with doing from sqlalchemy.orm. We'll import in what we need here, our declarative base class, and mapped and mapped column. So we can create this, and we're also going to need relationship. We'll need to import a few other things, but we'll start here. So our first one is going to be our base class, which is going to be our inherit from the declarative base. And we can just do pass on this. Right, now we can actually create the models that we want. So the first one is going to be our product model. This inherits from our base class that we just created. Now what's cool with this is we can do table name, and we can set this to something else. So we can call this products, for example, which makes a bit more sense. So we need to decide what information we want from the data that we're going to pull out. Now, from looking back at the schemas, there's all sorts of information, but what I'm going to suggest is that we get, we have an ID, which we'll use internally, maybe the name, description, SKU, and we're also going to have a foreign key, many to one, where, one product can have many, one to many rather, so one product can have many offers, and that's how we're going to compare the prices as we go. So every time we scrape more data, we're going to add more offers against the same product so we can see any changes over time. So we'll do our first one is going to be our ID, and this is going to be a mapped integer, and this is going to be equal to a mapped column, and we'll say primary key here is going to be equal to true. So this is our this is going to be our internal ID. Then what we'll have is name, mapped string, mapped column, and we'll say this is a string, which we're probably going to need to import in. Yes, we do. We'll do that in just a second. There we go. From that import, that's right. And we'll have this one can be. We're going to need to have a name, so we'll say nullable is false on this one, and now we can have a URL. This is also going to be useful for us to hold. Map string, I think there's a URL type which you could use maybe. I don't think it's important though, because we're using an SQLite database. Now we'll have our mapped column, not collection, mapped column. Again, I'm going to make this a string, and this one can be nullable. Let's just put this as nullable is equal to true for the moment. I'm not sure if that's relevant for us. They're not really going to be able to. Well, maybe some of them don't have the URL, so we'll leave it like that. Description. I might leave the description. Let's leave the description and let's put it in. We'll have it. So let's have description. Again, mapped string, mapped column, and nullable. This can be null if it needs to be. What's wrong here? Oh, I haven't done. I missed an equals. Right, SKU. Let's have mapped string is equal to mapped column, and this is going to be a string because these are it's not integers, it's not always letters. It's usually letters and numbers, sometimes dashes. And we'll have this one is going to be important because we want to have unique is equal to true, because we only want to have one product with one SKU. Otherwise, we'll end up with like loads of entries into the database that we don't want. And nullable is equal to false because this has to be something. And I need to just change this to a lowercase u. Then I'm going to have brand. This is usually inside that schema, which is also probably going to be useful for us. And again, maps column, string, and nullable. So you kind of get the idea. I'm just going through and creating all of the databases. This can be nullable. If there's no brand, it's not that relevant. It's not that relevant to us. Now this is always a good field to have, your created at field, and we can do this in automatically. Date time. Let's go alchemy. Do I need this? No, I need the actual Python date time. Okay. Let's import it ourselves, seeing as it doesn't want to do it for me. So we can always see, when things were created, etc., etc., which is going to be really useful for us, and it's going to do it automatically. If we do this, we do mapped column, Then we have our date time, which is from our SQL Alchemy, this one. And we do server default is equal to func.now. And this func is also from SQL Alchemy, this one, I think. There we go. Func.now. And we'll have nullable as this one as well. Nullable is equal to false. So this is going to automatically add our created at date whenever we add the record to the database. It's going to automatically do this created at for us, so we know that this went into our database at this time, which is really useful to know. So then we're going to have offers, and this is going to be a mapped capital M list, and it's going to relate to the offers with the offer table, which we're just about to create after this. And this is going to be a relationship, and this is going to be back populates equals to product. So this is going to bring the information back into us here. So that should be it for that. So now we need to create the offers table, offer table, isn't it? So base, and then we do the table name can be equal to offers. There we go, cool. So the first thing I want to do is, again, we'll have our own ID. In fact, it can be the same as this, can't it? Put this here, same thing. Then we'll have price, which is going to be a mapped. I normally use decimal for the price. Do we have decimal? We do. SQL Alchemy, decimal. Cool. Let's try that. And we'll do mapped column, decimal. Don't know why it's in caps, and then nullable is equal to false. We don't want it if there's no price. It's no use to us. Availability is a good one to store as well. We can see how the availability changes over time. Availability. This is going to be a string equals to mapped column string, and this could be nullable is true. We don't, if it's not there, that's fine. We don't need to know if it isn't. And we'll have the created at as well. This can be the same as this again, so we can see when this record is added. Now we need to do the mapping to the products column. So we have our relationship. So we want to have our, let's map it back to the product ID, which can be mapped int, and this is going to be equal to a mapped column. And this is where we have our foreign key, which we need to put in here. SQL Alchemy foreign key, yep. And this goes back to products, and this is like calling the table name, because the table name is products, and the ID. So we're going to go call it back to there. And again, nullable is equal to false because this can't be null. And then our product is going to be mapped back to the product table, and this is our relationship. And we do back populates here. Back populates is equal to offers, which is our table. So with the new way of SQL Alchemy, you can have the tables in any order in your code, because we just map the two together and it's happy that it knows it. It's mapping here a list, so each product can have a list of offers attached to it, which is obviously many, and the offer is mapped back to one specific product. So that was a lot of work, but this is the kind of like the core of the we don't need mapped collection. This is like the core of your project, because you need to have something to put your data into. Your data has to go into your database, and you need to map it out. So once this is kind of done, and this is like the hard bit, then it's pretty much plain sailing from there. So yeah, just got to figure out what bits of data you want and create your database like so for it. So now I'm going to go over to the main file. So we'll do main, which is currently empty. And I'm going to do from DB, and we're going to import in our session, which we created, our session local, and also that initialize DB function. Then we're going to do from models, and we're going to import in product and offer, which are both of our models. We're going to need these. Then we'll do from, let's just do import HTTPX, which is what we're going to use to make the requests. From rich, I'm going to import in print, and also from rich.logging, I'm going to import in the rich handler, because we're going to be using rich logging, which is really cool. It's really it gives you brilliant looking logging straight away for no real cost or anything. So and then we just need to import in logging as well. So we'll start with that. We will need to import in some other stuff as we go. But what I'm going to do now is I'm just going to do the logging bit, so it's done and out of the way. So whenever we get to starting to run our code, we can just have this ready. So all it does is it just gives you a format of a message, and we're saying that our basic config is logging level debug, which is going to be everything. The format is just this, with a date, and our handler is the rich handler. I've got into the habit of sticking this into pretty much all of my code, and it makes a world of difference to being able to see and clearly understand what's happening in your project and when you're trying to run it, which is also extremely crucial when you run this on the cloud or anything like that, etc. You need to be able to see what's going on. All right, so the first thing that I want to do is I'm going to import our URLs, and we'll scaffold out our project, and we'll build it up from there. So the first function is going to be to get the URLs, because we want to have them imported into our code so we can loop through them, etc., etc. So I'll do with open, and this is urls.csv, and we're going to need to import in the CSV module, and this is going to be, we only want read as f. Then we can do our reader is equal to CSV. Do I have this? Will it import it? No, it doesn't want to do that. CSV.reader. So let's just import CSV here. Cool. And let's have, we need to put in the file, f. Then I'll say our URLs is going to be equal to, and we use list comprehension, URL of the first index for URL in reader, and then we're going to just return our URLs, which is a nice neat list, and we don't need this line here. So when you import from a CSV like this, like I'm going to show you, you need to just index the first, otherwise you get a list of lists or a list of tuples, I can't remember which. So let's go and fill out our URLs. So let's just open that up. I'll just grab these over from my other, there we go, let's bring those over. These were the same URLs that we were working with before. So let's go back to our main file, and let's have our create a main function, and then we'll have our if name is equal to main. This just is going to say, hey, if we run this file, run this. So normally I'd have main in here like this, but I'm going to comment that out because we're just going to print get URLs. And now I need to run this. So I'm going to create, I'm going to exit this for the moment. I always forget to do this first. I'm going to create a new tmux session. However you choose to get to your terminal. Okay, so let's go and run this. Oh, I need to run main. I've got some errors. Mapped column, nullable. I spelled nullable wrong. Okay, fine. There we go. Nullable. Right. Fantastic. So that's our URLs. Nice and neat, nice list of URLs that we've got there. Okay, so let's go back to our main file and let's build out another. Let's get rid of that. We don't need that there. Let's build out our next function. So I'm thinking about getting the data now. So I'm going to do get HTML. I'm going to show you something cool in here as well. So we have URL, which is going to be our string. And I'm going to say that our response is going to be httpx dot get. We're going to say the URL is going to be equal to the URL. And I'm just going to quickly put some headers in here. We're going to need a user agent header. I would normally do this as a client, but we're actually only going to be doing, I put my user agent in here. I would normally do this as a client, but we're actually only going to be making one request from here. So I don't think there's no real need to. We can just do this, headers is equal to headers. And now we can go and say, let's do if response.status code does not equal 200. So we don't want a program to crash. We don't want our program to end if we get a 400 or something like that, because maybe the URL disappeared. We're going to get a 404. So if you did raise for status, it would just end your program. So I'm just going to do logging.info, and we'll just say something like URL responded with bad status code, response dot status code, and I need a cool. So that should be fine. So that just means it's going to tell us, hey, this went wrong when things happen. And now we can just put our else in here, and we can say let's do. We want to extract the data. Now, this is a really cool package which I didn't know existed, but I really should have done. So we're going to do from extract dot JSON LD. We're going to import in the JSON LD extractor. So if you watched me earlier talk about how there's a load of JSON data within that tag, this actually gives us a really easy way to extract that without having to do any of it ourselves. And it says to do something like this, we can create a JSON LD extractor, an instance of the class, and then all we do is we give it the data, we give it the response.text. So we don't have to do we don't have to give it a parsing or anything like that. We can just say it all comes with it in built in. So we can just say, yeah, here's the response.text, and we can just return out the data. And inside this data is going to have a list of all of the JSON LD plus, the application JSON LD plus whatever it is, those LD tags. It's going to have all of the information neatly formatted as a list of dictionaries. So we don't have to do any of it ourselves. Yes, it's another dependency, but it's going to save us time in the long run, I think. And so far, it seems to be working really well. So now I'm going to try this out. So we're going to come back here and we'll say that our URLs is going to be equal to our get URLs. And now we can do for URL in that list, we can do, let's just print out, actually no, let's say, no, let's just print it for now. Our get HTML of the URL. So let's swing back over to this part of our project and run it. So you can see all of the debugging, everything, there's all the logging, and you can see the data is coming back. So let's just scroll back up. So you can see here's the information from one of the shops, the end of the URL. So we had this schema, this lovely formatted data. Now you can see it does pick up the other one, so we're going to need to just filter that out, but that's really easy. And we can see here's the because I'm on this is the debug logging. I think I left it on debug, and so you can see all of the request response data that HTTPX is doing for us. Here's some more. Here's more of the data, so you can see here's the information we're after. I think it might be up here actually. Yes, this one. So this one's interesting. So we have the products and the offers, but it has all sorts of different products within the same like parent product. So what we'll want to do is, if I scroll down, it's just flipped around for this way for some reason, is I'm going to match this SKU against the offer, because these are all different products that we're not necessarily interested in. Here we go. And I think did I see one that failed? No, that seems to be fine. There's more of the data that we wanted. I'm going to trim the logging down once we're happy and satisfied. Here's the more. So did we get a good response from everyone? I thought I saw one that failed. Nope, seems to be fine. Perfect. Great. So we'll put the logging off the debug once we've got going a bit better, a bit further. So, but now we know that this is working and we're getting this data back out, we can actually start to think about using it. Now, to use it, we want to basically save it into our database. So let's go ahead and give this a variable, something like, I think data is probably fine, or let's call it product data maybe. We need our equals here. Cool. Now, what we want to do is we want to say for, let's think. So this is going to give us a list. So we want to say I'll just call this data in product data. We want to do, this is where we want to have our if offers, because we want to only get the dictionary from the list if it's in data. So if it's in there like this, like so. So now if we were to print out the data here, and if I change let's go back up to the top, and let's just change the logging level back down to, let's put it to info, it should be fine. And let's run this again. We should see that we only get this information back. And if we go back to scroll mode, please, Tmux. There we go. So now we're only getting back the printing out the information for the schema that has the offer in, so we're missing all of the extra ones which we don't need. So now we know that that's good. We can sort of proceed on to thinking about how we're going to store this information, and this might be none. Okay, that's fine, I don't care. How we're going to store this information into our database. So the first one we want to do is we want to load the product, because we need to have the product loaded before we can load any offers against it. So I'm going to call this one load product, and this is going to take in a session and some data. Let's give ourselves a little bit of room here to work with. So I'm going to say that our new product, let's call this new product. It's not technically, might not be a new product. It's going to be equal to an instance of our class product, which is our database model and our database table. So we can say our name is going to be equal to data, and we just need to fill this in here. So the URL I think I put as not nullable models. Let's go back up. URL nullable is equal to true. Okay, so what that means is we can, let's come back to our main file, is when you use the square brackets and the key like this on this is a dictionary, this data is going to be a dictionary, it will fail if this doesn't exist. But if you do this instead, and you do, we'll do URL data.get, and we say URL like this, if, I didn't want to do that, if URL doesn't exist, this is just going to become none, in which case, it won't go into our database. Then we can do description. I should have done is equal to data. I think I did the same here, so we'll do data.get description. And this, if I do, this is going to be, it doesn't matter, we'll leave it like this. Description. And then SKU is equal to data SKU, and brand is equal to data brand name. I've mixed these up. I really probably should have used the same one consistently throughout. We'll see if it bites. We'll see if it comes around to bite us on the ass, but maybe it needs to be a bit better than that. That'll do for now. So now we want to add them to our database. So basically you do session with our database session.add and then put in our new product. But the problem is that if this is going to try and add a product that already exists, i.e. because our SKU, which we set to unique, is it has to be unique, it'll fail and we'll get an error and our program will crash. Now the error that we get is an integrity error. So what we want to do is we want to do something like try here, and we'll do session.add, and we'll say our new product. And if that is successful, it's not enjoying my, is this where? Yeah, there we go. Then if that works, we can do session.commit. Now I am going to just do a commit for each one. You can do bulk commits, it's probably a better idea. And I'll say that our new product, I don't know if I'm going to need this, we'll say, let's just do product is equal to session.refresh. And we'll give it the new product here as well. So let's just kind of refresh our session, and that should give us the new product data back. And then we can just return that product. I think that's how that works. Cool. So that's if it works. Now, if it doesn't, we need to do an exception. So we'll have our integrity error here. And if I started typing integrity, it's not importing it itself. So I'm just going to go back up to the top. And I think it's from SQL alchemy dot exceptions. and we import in integrity error. There we go. That's the one we want. Let's go back down here. So this is going to be our exception. Our exception is going to be the integrity error as error. We have a couple of choices. I'm going to do, it doesn't like my try and accept indenting. We'll print the error out. In fact, no, we don't want to print the error. We want to logging.warn, and we'll say we need to make this an F string for our logging, and we'll just say error. That'll be fine. I'm not too worried about that. But that's fine. But the most important thing that we want to do is we want to do a session.rollback, because it's already going to have tried to do this. So it's tried to do this, and if it fails, we need to roll the session back so we still have access to it. And then I'm just going to return new product back out. So it's there. I don't think we need this, but just in case. So this is essentially what we're going to do. We're going to take the product data, we're going to push it into our model, and we're going to try to add and commit. If that fails, we do on integrity error, we say, hey, this has failed on this error, and we roll back. So that's essentially what we have to do, and we're going to need to do that for the offers part as well. So let's look at trying to get some products into our database. So at the moment, we're just printing out the data here. So I'm going to do, we don't need the print. We're going to do load product, and let's have this as a variable, because this, what do we want to call this? My brain is not functioning. Let's just call this one P. That will be fine. And then we can give it the session, which should have come from our, I've missed that. Oh, that's fine. That's cool. So up here, we need to do, we need to initialize our database. I imported it, but I never ran it. That's of course. Now we can create our session, which is going to be equal to the session local that we imported at the top. Perfect. So now we have our database initialized when we run this, and we have our product here. So this could throw an error now because I never did this before. So if I did anything wrong with the database, we might get some issues. Let's run it. Cool. I didn't see any warnings or anything like that. It looks like we put the data in. So let's check. Now you can, of course, you can use a few different ways to check what's in your database. There's DB Browser for SQLite, which is a graphical user interface, which is pretty good. I'm just going to do SQLite 3 in my terminal, and this gives us this, and we can just do .open products.db. We get that, and then we can just do .tables or .table, and it shows our two tables. And then we can just run SQL queries from here. So I'm going to do select star from products. I'm just going to check that we've got something in there. We do. So this is why I wasn't sure about the descriptions. I think we probably want to redo this and do strip the white space from this. But let's just select the, what should we do? What did I call it? SKU, or let's just do ID, SKU, name. Cool. So we now have 4 products, and I think I put in 4 URLs. 1, 2, 3, 4, 5. Okay, so 1 is failing. Fine. So now we have 4 products in here that we can see in our database, and we can just get out of this here. And I didn't mean to close that tmux window, so let's just get that back. There we go. Cool. Right. So now we know that we're loading the products and it is working fine. That's good. I'm going to get rid of this print statement. I don't need this at the moment. So now we are loading the products, we need to load the orders as associated to these products. In fact, let's run this again so we can see that we should hopefully be getting that warning. There we go. There's our first warning. Integrity error, unique constant failed, which is exactly what we're expecting because it's saying, hey, this already exists in our database. So now what do you think about loading in the offers? So we're going to build ourselves a load offers function like so. Let's call it load offers. And again, it's going to take in the session and also the same set of data. We need to think about this a little bit more because as I showed you in some of the in the JSON schemas earlier, that some of them, the offers was in a list, and some of them it was not in a list. We'll cover that in just a second, because the first thing that we need to do is find the product that is associated to the offer. Now, when we get this in, we would have just we'll have just loaded the product, or we've skipped over it because the product doesn't already exists. So I'm going to say our product is going to be equal to session.query on our product model. Then we can do .filter against the product.skew is equal to the data skew here. And then we want to do .first, so it returns us the first thing. This is going to get us that product because obviously the skew is unique, and the skew is going to come from the data that we just scraped. So we're going to do that here. What we want to do now is we want to check to see what sort of data the offers is. Now, in some of them there was a list, in others it was just a single dictionary. There's a few different ways you can do this. The way that I solved it was if is instance, and then we can say data offers. This is the key inside our dictionary that we've scraped. We can say if this is a list. So what I'm going to do is I'm going to duplicate a little bit of stuff here, which isn't ideal, but this does work, and given a bit more time I probably would maybe sort this out a little bit. I'm going to do for offer in data offers, and we can now go ahead and create the new offer. But what I want to do here is what I talked about when I showed you before. The offers for that one product had, one parent product had lots of different SKUs in, and we were focusing on one. We don't want to have, one product SKU and then, loads of offers that have different product SKUs in. So I'm just going to say if offer SKU is equal to our product.skew, which is the product we pulled from the database here. So this is just going to give us that. So now we can create our new offer. And this is going to be equal to an instance of our offer model, and this is going to be price is going to be equal to the offer price, and the availability is equal to offer .get. I'm going to do here because this was not available in every one, I think. So this will again handle that for us, and then the product ID that this is associated to, again this is another database table, is going to be equal to the product that we've pulled .id. So this part here is that field in the database. If I go quickly back to the models here, this is this field that we're mapping to the foreign key. So this is this one, and we're saying it's going to equal to the product ID that we pulled from our database here. So we're mapping everything across nice and neatly. Now what we can do is we can have this again. Again, I know I'm duplicating some code. I'll put this in here. Oh, I didn't copy it. Oh, I did actually. Or did I? I did. So we can put this in. Indent this. Put this here. And this needs to be new offer. I don't think we need this bit because I was planning on doing something with the data that comes back once it's been added in, but I'm not. But we're going to do it. We'll just leave it like that anyway. So this is going to handle it if this is an instance of a list. So we just need to do it if it's not an instance of a list, which is where we're going to do a little bit more code duplication. Maybe you'd want to split this out into two separate things, or maybe you would create a maybe we'd split this out and have a like a loading function that we could call. But basically what I'm going to do now is I'm just going to do this, and I know what you're going to say, but we're just going to do that, and we're going to go if, I'm going to say else because this is not, no, this is going to be, I need to zoom out a bit. So if it's an instance of the list, we're going to do this. Else we're going to do this. And the only thing that needs to change is some of this does not the same. Oop. Let's just fix my indenting. And now we just want to, because this is now inside the data, so we do offers price, and availability is going to be data offers dot get, like so. And this is going to be the same. This should be the same. And just get rid of this. Let's just get rid of this. I don't need this. Don't need that. We don't need this. I'm going to get rid of it. This is clogging up my stuff. There we go. Cool. Right. So again, I know that I've duplicated a lot of stuff here, and this was only because of this way that, you know, the list was, one of them was coming back as a list, and I needed a way to handle that. So I think tidying this up would probably be a good idea. However, this should work, and we now can say with our load offers, our data, and let's come back here, and we'll probably have something that we need to fix because I just typed all of that out. Offer availability is an invalid keyword. Okay, so I've done something wrong. I misspelled availability, no problem. Let's run again. And we're getting stuff added in. Nope. Okay, so this is where I needed to do this. So it doesn't exist for one of the items. There we go. And now we should run. And it's just going to put none in there instead. There we go. Cool. Cool. So let's check out our SQLite again, and let's do .open products.db. Let's do select all from our offers table, offers, where product.id is equal to 1. Products. Oh, I'm doing the wrong thing. Products. It's this key here. There we go. Cool. So now I have 3 entries for this product that are the same price. The first one was when I had an issue with the availability, which is why it isn't in there. So what I'm going to do is I'm going to exit out of this. I'm going to remove my products.db. We're going to clear, and we're going to do PyMain, and we're going to run again. Always catches me out. And we're going to start adding some data in. So this should be one lot of products, and we should now be adding in. I mean, it's the same offer over and over again, because obviously, you know, we could do it at different times to maybe get some different prices. But I'm going to put some data into the database so it's available for us. Let's give it another one. Sweet. So let's go SQLite 3, and we'll do .open our products.db database, and from select all from offers where product ID is equal to 2. Cool. So there we have it. So now we've got these entries and the date and time that they were entered for them there. So let's close out of this and come back to our code. That's pretty much it, really. This is kind of like a bare bones kind of skeleton to a project where, you know, we take the URLs, we take what we looked at earlier, where, you know, we can find the data in that schema as JSON. We use this cool JSON LD extractor tool to do the handling for us. This one function here, this is the scraping part. That's it. The rest of it is, you know, passing it and adding it to the database and our models, etc., and everything like that. So, I mean, that's just kind of the way it is. And then we just run it all down here, which is quite neat and tidy. So it's basically 100 odd lines of code. To improve this, what I would do is, if I was going to be running this a lot, I'd be tempted to put in some more validation in here and handle this load offers a bit better maybe, but this will work fine. We are pulling in specific structured schema data, so this isn't going to change, which is good for, you know, when you instead of trying to like parse a load of HTML, this isn't going to change, so that's good. But, you know, we would want to put in something like Pydantic to validate it first so we can avoid any extra errors, but that's generally better for when you're taking in user submitted data. We didn't need print here, and I imported that by accident. There we go. So what I'll do is I'll put this code all on my GitHub for you to have a look at, and, you know, maybe decide what bits you like, learn from some pieces, take something away from it maybe. But this has been quite a long video and like more of a full project, so hopefully you've enjoyed it and got something out of it. If you still want some more coding after this, which of course you do, make sure you subscribe to my channel and check out this video here, which is more on web scraping data rather than building something like this to save it.